Imagine walking across a frozen lake in the middle of winter. The ice beneath your feet may be 30 centimeters thick. In a harsher winter, it can reach a meter, or nearly fill a shallow lake. Snow covers the surface. The air is far below zero. Yet somewhere directly under you, a fish is still moving. No sunlight, almost no food, and sometimes barely enough oxygen to breathe. So how does anything survive down there? And what if there is no water left at all? In some shallow lakes and ponds, winter ice can reach all the way to the bottom. If that happens, where do the fish go? And why can the same water be full of fish again in spring? The first trick begins with something strange about water. As a lake cools, the coldest water stays near the surface. Fresh water becomes heaviest at about 4 degrees Celsius, so that water sinks. Water colder than that stays above it. Then the surface reaches 0 degrees Celsius and freezes. But ice floats. Instead of the lake freezing from the bottom upward, it forms a lid. And that lid actually slows further cooling. So beneath a frozen northern lake, there may still be liquid water only a few degrees above freezing. For many fish, that is enough. Their body temperature falls with the water. Their metabolism slows. Their heart rate drops. They move less and need less food. Some fish spend much of winter in deeper water, almost as if the entire lake has switched into slow motion. But cold is not always the biggest problem. The real danger may be something you cannot see: oxygen. Once ice covers the lake, wind can no longer mix oxygen from the air into the water. Then snow lands on the ice. Less light reaches the plants and algae below. Photosynthesis slows. But fish, microorganisms, and decomposing material continue using oxygen. Week after week, the lake can slowly run out. In shallow lakes, oxygen levels can eventually become extremely low. This is why a lake can have plenty of liquid water under the ice and still become a terrible place for fish. And some fish are much better at this game than others. The Crucian carp lives in ponds and small lakes across northern Europe and Asia. Some of those ponds lose almost all usable oxygen beneath the winter ice. Most vertebrates could not remain active in those conditions for long. The Crucian carp can survive complete lack of oxygen for weeks, and at very low temperatures, even for months. Its solution sounds almost impossible. It starts turning stored sugar into ethanol. The fish then releases that ethanol through its gills. Experiments have kept Crucian carp without oxygen for as long as 140 days. Before winter, the fish builds enormous stores of glycogen, stored fuel that helps keep this system running. So while another fish may face an oxygen emergency, the Crucian carp can enter an extremely low-energy winter mode and wait. But now take away the last layer of safety. What happens if the lake does not just freeze on top? What if the ice reaches the bottom? For most fish, this changes everything. A normal fish is mostly water. If ice crystals begin forming throughout its tissues, those crystals can disrupt cells. So a trout, perch, or pike cannot normally become a solid fish-shaped block of ice in January and simply swim away in April. If a small pond truly freezes solid, its ordinary adult fish population may not survive inside it. And fish eggs are not a magic backup system either. Some species lay eggs in autumn, and those eggs spend winter beneath the ice. Lake whitefish and several salmon relatives can do this. But the important detail is that the eggs remain in liquid water, often among gravel on the bottom. They are cold. They are not normally frozen solid. Research on salmonid eggs shows that once ice begins forming inside the egg, survival becomes a major problem. So if an entire pond genuinely turns into solid ice, saying the eggs survive and replace the fish usually does not solve the mystery. Except nature has produced one fish that makes this story much stranger. The amur sleeper is a small freshwater fish from northeastern Asia. Scientists describe it as the only known fish capable of true freeze tolerance. Not just cold tolerance, freezing. Researchers have found that it can survive with ice forming in its body and later recover after thawing. In laboratory experiments, amur sleepers have been held at around -2 degrees Celsius for 24 hours and then returned to water at 4 degrees Celsius. Some recovered. Studies suggest they protect themselves by slowing metabolism dramatically and increasing substances such as glucose and glycerol that help protect cells during freezing. So yes, a fish can, in an extraordinary case, appear to wake up after being frozen. But this is the exception that proves how unusual the ability is. Most lake fish survive winter by avoiding freezing completely. And that leads to one final mystery. People sometimes visit a tiny pond in winter, see ice apparently reaching the bottom, then return in spring and find fish again. It looks as if the fish came back to life. Usually, something less magical happened. The pond may not actually have frozen everywhere. A deeper pocket can remain liquid. Groundwater can enter from below. A spring can keep one small area above freezing. Even a thin layer of water beneath the ice or inside bottom sediment can be enough for certain small fish. And if the population really disappeared, the pond may not stay empty forever. Spring floods can connect waters that were isolated during winter. Fish can move through temporary channels. Humans can stock them. Connected streams can refill a pond with life. Sometimes the fish you see in April are not the same fish that were there in December. That is what makes a frozen lake so deceptive. From above, winter looks like everything has stopped. Under the ice, some fish are simply waiting in cold water. Some are surviving almost without oxygen. One remarkable species can even survive real freezing. And in the smallest ponds, spring may not wake the old population at all. It may bring a new one.